Hello and welcome to Mechanical Fluids, and my name is Mohammd Makki, and today I'm going to show you how you make your own flow simulation. And as you can see, this is a centrifugal pump, which is easy to make, and you can see this is the inlet, goes in steady feed, make sure the display and to the environment, to the atmosphere. So let's go ahead and start. Let's make a new part. So you can choose whichever plane you want to choose. I usually use a front plane. It's easier for me. I can use either any of the units depending what you downloaded at the beginning. So it's SI unit, the American system unit. You can choose. So we're gonna make now the inner circle with the blades. And then the other circle should be as double the size of the inner circle, which be between the two circles, and gonna make your own fan or blade for the pipe, or for the pump. Sorry. 1, 2, 4. Then you're gonna use the 3-point arc, and we can choose however we want to make it look like. So you press the arc again, and then just close enough. And then you go use the trim entities, and you're gonna trim the outer circle. So now you want to repeat it, blades all surrounding the whole circle. So you're gonna go to the linear sketch pattern, and you're gonna choose the circle sketch pattern, and then you're gonna choose your parameters point as where it's gonna be circular around it, and then you're gonna choose your entities. So you're gonna pick up all these lines, and as it shows, let's make it 5. And then we're gonna make another trim. So you're gonna make the whole thing as a one piece. So you're gonna trim in between the circle and the blade, so you get it as a one drawing. After that, you're gonna go to the feature, and then you're gonna do the extruded base, and I'm gonna use in the direction of the mid plane. Make it, I don't know how much I made that and check. Made it at 0.01, I guess. And then press check. I didn't pick up the material, as the purpose of this is to show the flow simulation, so it wouldn't matter in this case. So you're going to draw another bigger circle. What just happened? Another bigger circle around this blade. Make it a little bit bigger. Let's make it. It's close to 0.045, and then we're gonna also do the extruded feature on it. So extrude face and then make it mid-plane and make it a little bit bigger than the inner circle you just drew, and take the merge result off as you don't want to connect this circle with the circle you just made, and yeah, so it'll be separated as you can see. So it will be one, will be a different kind. Of course we want to keep the inner and then hollow shell the outer circle, and that's why we separated it by taking the merge results off. Now we're going to show the inlet of the pump. So that's why, as I was telling you, choose the front plane as most of our work for the pump will be for the front plane. And let's make our dimension 0.015, bigger than the inner circle, and then we're gonna use this extrude feature again, and then we're gonna make it longer as it's an inlet 0.7, and also, yeah, don't forget you're gonna extrude the merge result. You're gonna take it out. Oh, actually it's gonna be with the outer circle, so it's okay. Then we're gonna make the outlet, so still as you can see, this is the front plane and you want to do the side plane of it, so then you want to make a path. So we're gonna make first a center line, and always remember to choose your plane, edit sketch for your sketch so you don't mess up with between your other drawing, and you go with center line with the center of the circle, and you make it as long as, let's say, 0.06, and we're going to draw another normal line below it, the same, and you have to keep it horizontal so it shows you that they are the same size as the dotted area, and then the 180 degree as being a horizontal line. Of course we need a smart dimension to put the exact separation between them, so that's 0.005, and this is all based on all in meters, so that's why you see 0.06. So looks like you're kind of making a smaller model of the centrifugal pump. And then now you want to put a circle here, but you have to make an extra plane. So for that, you're gonna go back and go to the features, and then you're gonna go to reference, and then insert a plane. You gotta pick up this line and then this edge, so face to the right side of where you want to put your outlet, circle, or how you want to make your pump look like from the side. So you pick that up. Now make it look in the normal side, and now we're gonna add our outlet circle. So in this part, you don't need to put your dimensions, as it's gonna interfere with our next step. So just uh, keep it the way it is, and then because you're gonna connect these two each other together, so you have to go back to the sketch, edit. So I'm gonna press this and press, so it'd be like consonant, consonant, and then you're gonna make the center of the circle to be consonant with lower with the lower line. You zoom in, and then take this point with the other point, and it's already like on point, so we're lucky here. Now we're gonna make our sweep feature, so we make our own pipe path to the pipe. So we're gonna go to features, and then we're gonna choose sweep, and then we choose the sketch and our path. As you can see, with the normal zoom, we just connected our outlet. And of course we want to separate the planes. So when we do, as you can see, if we did that, let's consider now it's a whole one drawing, so we won't show our inner circular blade. So that's why we use to edit, take the merge away, and then edit, take the merge away, and then as you can see, look, now do the same thing with the sweep. So options over here, and then take the merge result away, and now it's kinda done, but now it's interrupting with our inner blades here. So what we're gonna do is we're gonna make our own, we're gonna combine the two so it stays away from the inner circle. So if you don't have fun combining it in top of your features, you can just search it over here, and then you're gonna combine these three together. And if you just do this section now, you're gonna see that they all separate each other, and they separated from the inner blades that you have. So now we're gonna do our own shell. So that's with the part why we took the merge results away from each other. So when we do our shell, it won't shell our inner circle. So just let me make it look normal. right size, and then we're gonna go to the feature up here and go to shell. Then you gotta pick up these two faces, the inlet and the outlet, and make it 0.01 for the wall. As you can see, it goes all through, and you can see through the outlet, the plate, that it's not being interrupted. And you want to make sure you can just do the section part here, and then you can see that it's only shelled the part that we need to be shelled from. Now, since we made our pump, now we gotta make the inner circle that is close to the blades as much as we can, so we don't ruin our drawing. We can do change transparency, so you can see all the inner part of your design, and so you don't mess up with your drawing. As you can see the inner of it. And so since we want to make it look in this orientation, you can choose your orientation from here, so you can or just do with the arrows, and then you can fix it like that. So, but of course you want, that's why I was telling you choose which plane you want to do it from. So I'm still doing the front lane in my case, and then get it close enough, and then we're going to draw the circle that are the inner wall that are close to the blades, but not touching them. And of course we're going to take the merge result away. We're going to extrude the base, and as you can see, for mid plane, and we're gonna make it a little bit bigger than the inner blades here. So as you can see, this is the right size, and then we'll still do a little bit bigger. You can even zoom in for more accuracy, and that should be good. That's close enough. And that's how we are done with our centrifugal pump. Last but not least, the merge result. Take it away, so it'll be separated from the inner circle, and then to make sure it changes transparency, you can see how it looks like and how it is shelled. And as you can see, this is how it will look from inside. Now we're gonna create our own lid, which is easy. Just gonna go to this plane, and then we're gonna add a sketch on this circle. We have to cover the circle so we won't have any openings. So make a circle center here and cover this area. Doesn't have to be the same. You can make it the whole thing or not, but as long as you can cover it up. And then we're gonna go back here, and then we're gonna use our own our old trick, which is using the reference. Oh, but before that, I forgot to do the feature, the extruded feature, and as you can see, we're gonna try and make it as thin as the wall, close enough to it. So it's like around this much, and as you can see, now we made our outlet lid, and then we're gonna make the reference again to the plane for our front lid here. So as I can see, we'll need a little bit push, let's say 5, and it's perfect on the surface of the inlet. Now we're gonna make our inlet lid also as covering the circle in the middle. Like I told you, it doesn't matter if it's same size or bigger, it doesn't matter as long as it covers the whole thing. And then we save our work, save as, and save it the same way you save all your files for the SolidWorks, so you don't have the trouble of not being saved and not going through. So now we got our centrifugal pump, and now we're gonna make our own flow simulation. Of course, if you have your own flow simulation license, you can get it through here, but also the SolidWorks tools have a different kind, which does all the work for you. So you go to Tools, Express Product, and then Flow Express, and just wait for it. And if there's no warning, that means your lids are perfectly fine and there's no other ends in your design. And as you can see, what the reason of what people use in SolidWorks is mostly for engineers. Now, do not base your decision solely on the result for SolidWorks Flow Express. Use this information in conjunction with experimental data and practical experience. So that's the whole reason of why we use simulations in small model, and so we don't need to waste materials, and we base it as a model to the prototype, and after you get your experimental data. So before you end, um, uh, let's go back again. So before you end, you don't check straight away, so you go to the next step here, and then it says the geometry there has not solid geometry. Oh, there's some opening, then there is some opening with the lead. So we're gonna go check our LEDs again, and we're gonna edit it. Oh, I forgot to do the extrude feature over here. So yeah, we didn't do that for this part, and the best part is already designed to the same size as we did it the first time. So then don't forget to always save, and then now we can do the right flow express without any wrong geometry. And as you can see, if we press next now, we got the right geometry, and then it shows you the view of the fluid volume. And then we only have two kind of fluids, so it's either water or air, so we're gonna go for water. And then let's put the volume at 0.01. Oh, and then specify the inlet I already showed you. So the inlet will be this side, and it shows you the arrows how it's gonna go in, and then we're gonna put the outlet, and then we're gonna go next and make it go to solve. As shows, it sometimes takes some time to get the whole process, but soon enough you're gonna see the flow simulation starting to flow from the inlet to the pump and then out to the outlet. Um, just give it some time, and you're gonna see the results that I showed you at the beginning. But since we started this, I'm gonna show you there's nothing wrong with your design as long as you follow these steps uh, perfectly. Now it's gonna show complete. And now you can choose either, as you can see, there's a pipeline, or you can make it go, it looks like balls, depends how you want to show your design. We can make more or to one, so we're just gonna make more pipelines and show our inlet flow and then to the atmosphere, and then you press play. You can see that how it's steady of it, and then as I showed the reference of our design. Hope this will help you with your future design, and it's a very interesting program to check your simulations. And there's also other simulation like for materials and stuff. That's why I mentioned we didn't need to use the change of materials over here, as we're just gonna go and check for our flow simulation design, how it will look like through a centrifugal pump, and how the basic of it and how it looks like. Hope this helped you, and thank you.